Hi, this is a 6-part tutorial series to make a complete platformer game in Gamemaker. The game we're making in this series includes momentum-based movement, wall jumping, a save and load system, and everything else you need to make your own platformer game. The goal is to help you learn about Gamemaker and what you can do in this app with relatively simple code. My name is Dr. Sky, and I'm a professor of digital media arts at the University of St. Thomas in St. Paul, Minnesota. This is part 2. In this video, you will learn how to add wall jumping to your game, as well as enemies, hazards, a simple combat system, and checkpoints. Before we do anything else, let's do some housekeeping. We got to do some cleanup. In Gamemaker, we can add regions to our code that we can title, minimize, and maximize. So we're going to add regions to this step event in the OPlayer object. So we're going to add the following regions. Let's start up here where it says get inputs. We're going to create a region. Oh, we have to have that little pounder hashtag symbol. Region player inputs. And then end region. Yep, that works. Next, we want to add a let's minimize that. This region will be called calculate movement. And we'll end it right before collisions. End region. Minimize that. Region collisions. Right after we commit, oh, I forgot to change that comment. There we go. After our vertical collision code and where we commit the VSP to the object's Y position, we'll do end region. End region. Minimize that. Region current status and animations. End region. Minimize that. And lastly, just quick region for game control. Look how much more clean this is. Now if we need to go to a section, we can just go there, we can maximize it, do whatever we need to do, and then minimize it so it stays nice and clean and we can find everything that we need. So let's add wall jumping and wall sliding to our game now. So first thing we need to do is to check to see if the character is on the wall. So let's go to the current status and animation section. And underneath the check for on ground, which is right here, we're going to add a similar check for the wall. Let's do on wall equals place meeting x plus 1, y o block minus place meeting x minus 1, y o block. Semicolon. So if this returns true, meaning there's a block to our right, this will be 1, and this will be 0, so on wall will be assigned positive 1. And if there is a block to our left, this will come back as negative 1 because we have the minus here. 0 minus 1 is negative 1, and so on wall will be assigned negative 1. So we can check on wall to see if it's positive 1 if there's a block to our right, or negative 1 if there's a block to our left, or 0 if there's not a block touching us on either side. So we're going to go to the create event. Be sure to do that and declare this variable under a section. Let's just call wall. On wall equals 0. Next, we need to add a new sprite for when the character is on the wall, and the new sprite that will make it look like the character is kicking up dust when wall sliding. It'll be a cool little particle effect. So let's create a new sprite. What? Did I not do it? New sprite. There we go. S_player wall. Import the appropriate image, which should be just one image, player wall. Set the origin to middle center. And we don't have to worry about animation speed because it's not going to be animated. It's going to be a still image. In the oPlayer object step event, or in the create event, sorry, under wall, declare a variable called dust equals 0. And in the step event, go to this adjust sprite section in current status and animations. Adjust sprite, this is where our animations are. And we want our new wall slide sprite to override the sprite when we're in the air, because if we're sliding on a wall, we're also not touching the ground. But we don't want to use the sprite for when the character is falling either. So we need this to override the falling in the air sprite if we happen to be touching a wall. So we're going to navigate to the not on ground section, or if on ground is false. And in this not on ground if statement, we're going to move these 3 lines of code and write some new lines. So in that section, make an if statement for if on wall does not equal 0. Open curly bracket, close curly bracket, and then make an else, open curly bracket, where we're going to put all this stuff. So meaning if we're on the wall, we should have a special sprite, but if we're not on the wall and in the air, we should just have the player air sprite. That's all it's saying. Now in the if statement for on wall does not equal 0, add these new lines of code. If, let me give some space so you can see it a little better. If, oh, actually, we don't need an if statement. We can just write sprite index equals s player wall, image x scale equals on wall. So if on wall is positive, the image will be appropriate for a block coming to the right, because if you remember, our sprite looks like this. And if there's a block to our left, so the character needs to be hanging on to that block, it'll switch it to -1 if on wall is -1. So little elegant code there. And on left wall, add a little comments to explain that to my future self. -1 on right equals 1. Let's check to see if it works. So we haven't added wall sliding yet, but when we're on a wall, we should get a new sprite that looks like the character is holding on to the wall, which it is. Only when it's in the air. See, if it's standing next to the wall, it's just the normal sprite, but when it's in the air on the wall, we get the wall sliding sprite. Now we need to add some dust particles. So the first thing we need to do is create a dust sprite and dust object. So create a new sprite. Call it s_dust. Resize the canvas to just be 2 pixels by 2 pixels. Really, really, really tiny. Edit image. We're going to make several images here. So I'm going to make this first image. Let's make it this like aqua color because that's the same as our character. Zoom in a little bit. We can't zoom in. Is that too far? First image, just make it all that color. And then our next image, just make it with the pencil tool, 2 squares in the 2 corners. The next image, do it in the opposite corners. And then the last image, just do it in 1 corner. Doesn't matter which corner it is. That way the dust particle will look like it's gradually fading out. Now remember, this is really small, so it'll actually look like it's fading out when we run it. And set the animation speed to 30, which it already is. The origin can be top left. That's totally fine. And let's close that. Let's create a new object. Call it O dust. Set the appropriate sprite. And in the create event, write v speed, vertical speed, which is a built-in variable, to this instance, random range negative 0.1, comma, -1, image speed equals random range 0.4 to 1. So it's vertical speed. It's always going to be going up. The dust is always going to be kicked up, so that's why both these numbers are negative, but it's going to be going at sort of random speeds. And then its animation speed is also going to be set to be either 30 frames per second or anywhere in between that and 40% of 30 frames per second. So the animation speed will also be different for every particle of dust that gets kicked up, but there's going to be a lot of particles of dust. So when they're all put together, it'll look like a lot of dust that's sort of moving in random directions and speeds. And we're going to add an other event, add event, other animation end, meaning when it's run through its 4 frames, we can write instance destroy, because we won't need that dust particle anymore. And bam, there we go. We have dust particle. Now, we also want to add a layer in this room behind the player and the walls. In the room, level 1, add a new instances layer, call it behind, and drag it underneath the instances layer, because if you remember, anything above anything else in this layer section means it appears above the things that are underneath it. Close that, and in the OPlayer object, in the step event, in the else statement for the not on the wall and off the ground, not on the wall and off the ground, which is right here, we will add dust equals 0. In the wall slide if statement, which is right here, we're going to write, move this comment here. We're going to write some code for our dust. Local variable, side, meaning which side the block is on, equals bbox underscore left, dust on left part of collision mask, because our wall slide, there we go, our wall sliding sprite, you see has some cushion on the right of it, and we don't want the dust particles to be kicking up from over here. We want to be the dust particles to kick up right where the character is sliding. And since it shares a collision mask with the OPlayer object, that will be right there. bbox means the bounding box or the collision mask of the sprite. So that's for the side that we want. If on wall double equals 1, meaning there's a wall to our right, side equals bbox right. If wall on right side, put dust on right. So it'll default to be on the left, but if it's not, if it shouldn't be there, if the wall's on the right, it will change to the right. So we don't need to add any additional code there. That covers both the left and the right. And then dust plus plus, which means essentially the same as dust plus equals 1. So every frame it'll increase in value. Increase dust variable by 1 every frame. if double parentheses dust is greater than 2, close parentheses, and open parentheses, VSP is greater than 0, close double close parentheses, after 3 frames of sliding down the wall, increase this a little bit. Oh, I forgot to add an open curly bracket there, close curly bracket there, with instance create layer side vbox top comma layer is the behind layer comma o dust double close parentheses open curly bracket. So with this with a new particle of dust that will just get created, and with whatever just gets created, add the following code, which is do this code with the newly created dust instance. Other dot dust equals 0. Change the player object's dust variable to 0. This will set the dust variable to 0 in the player object. H speed equals the opposite of whatever the player object's on wall value is, but half of that, 0.5. So its speed will be going the opposite direction of the wall at 50% of the at 0.5. 0.5 speed. It's a little slower than 1. Gives a horizontal speed to the dust, opposite of the wall we're sliding on. So dust will now come off the wall once every 3 frames. Let's see if it works. Yep. See little dust particles. Now, if we want the dust particles to fly off further to the right or to the left, we can just remove that 0.5 of the dust H speed. But I think that looks good. Now we'll get started on the wall jumping and wall sliding. In the create event of oPlayer, declare a variable for wall gravity, meaning when we're on the wall, we want the character to be going down slower because it's as if the character is grabbing onto the wall. So if our typical gravity is 0.4, let's make wall gravity equal to 0.1, which is a lot higher, so we'll be going down a lot slower. Gravity is reduced when sliding down on wall. And we're going to add variables for wall jumps. So our horizontal speed for wall jumping, so HSP W jump, is 4. Max HSP for moving away from a wall during a wall jump. Jump speed underscore wall equals -7. So I want the character to not go as high vertically if they're jumping from a wall. How high you jump during a wall jump. And max VSP wall equals 4. Is max falling speed when wall sliding. Let's go to the step event. And let's close this region and go to the calculate movement region. And locate the calculate horizontal movement section right here. And add a new section underneath that, right above the calculate vertical movement. And call this a new section called wall jump. If on wall does not equal 0, meaning we are on a wall, and on ground is false, meaning we are in the air, and key jump is pressed. Open curly bracket, close curly bracket. So this means on wall, in the air, and jump key pressed. Change HSP to be opposite the wall, jump away from the wall. HSP equals negative on wall multiplied by HSP underscore W jump. Change VSP to jump vertically differently than from the ground. VSP equals jump speed underscore wall. It's going to disappear. It's not disappearing, so something's up. Oh, one wall. I misspelled this variable. Let's reduce that. There we go. That disappeared. So we're not done yet. At the first line of the calculate vertical movement section, which is right here, we're going to take this and we're just going to delete it. We're going to make the gravity way more complicated, but this is important because we're going to be deciding between different gravities and different clamps. So we're going to create some local variables here. Var grav final equals grav. Import grav from create event. Var VSP max final equals max VSP. Import max VSP from create event. So these final values will be just the default gravity, default max VSP if nothing funny is going on, but we can change these values to be something else if we're like sliding on the wall or if we're falling in the air. If on wall does not equal 0 and VSP is greater than 0, meaning we are, if sliding, oh, open curly bracket, close curly bracket, good habit to get into, add those immediately. If sliding down on wall, grav final equals grav wall. Slide slower than in the air. Grav wall, why is this not? Okay, that's still good. VSP max final equals max VSP wall. Slide slower than in the air. So this gravity is just like acceleration, so it's how quickly we get to max VSP, and then max VSP is like how our max sliding down speed. And then here, all of this will be ignored if we're not wall sliding. So you can just ignore it, and then it'll just be reading this, and then it will set VSP plus equals grav final, whatever is appropriate. If we're just falling in the air, it'll just do typical grav. And if we're sliding down a wall, it will do our wall gravity, and we'll add it here. And VSP equals, oh, we're going to add that clamp back. So let's find that clamp. Let's remove that clamp from down here at the bottom underneath ground jump, and let's just make sure it's up here at the same place. VSP clamp VSP minus VSP max final, comma, VSP max final. And everything should look good. Did I do something wrong here? I have this caution here. Variable grav wall only referenced once. Oh, I called it wall grav in the create event. Let's change that to grav wall. There we go. Grav wall. There we go. All right, let's test it out. So when we slide down a little slower. And and we jump from the wall just a little bit. But also you should see a problem here, that if I hold the right key and I'm on the right and I just keep hitting the jump button, I can perpetually wall jump on one side. Now, if you want your game to do that, you can do that. It's kind of fun. But I want to make it so the player kind of loses control for a little bit, and so you can do wall jumping back and forth. Because right now, you don't do that. You kind of just stop jumping there, and you can just perpetually hold one key and just perpetually wall jump up. So let's fix that issue. We're going to just go to the create event. And player loses control for 20 frames after wall jump. Wall jump delay equals 0. Wall jump delay underscore max equals 20. Now go to the step event, to the calculate horizontal movement section, which is up here, and make the first line comment. I'll indent the comment. Will reduce wall jump delay by 1 every frame until we hit 0. Wall jump delay equals max. Wall jump delay minus 1, comma 0. Next, we wrap the entire contents of this section, the calculate horizontal movement section, horizontal speed, after the first line in curly brackets with an if statement. So we have this, and we're going to wrap all of this into an if statement curly bracket. So let's do this. Let's see if I got this right. If wall jump delay double equal sign 0, open curly bracket, and then close this. And what this will do, new comment, won't be able to move left or right until this equals 0. I can't remember if I need to put this clamp outside of that curly bracket or not. Well, let's just test it out and find out. So right now, the wall jump delay has to equal 0 in order to move left and right. And the wall jump delay will always be reducing to 1. And yes, I might need to add wall jump. Yes, to the first line of the wall jump if statement, which is right here. We will write wall jump delay equals wall jump delay underscore max. Comment just wall jumped, so no horizontal movement. So wall jump delay will be set to 20 after we wall jump. And so for 20 frames, we won't have access to this code. And then after it hits 0, we will be able to wall jump again. And this wall jump delay will always make sure it doesn't get below 0. It's set to reduce it just by 1 until it gets to 0. So let's test it. Now I should be able to jump from wall to wall, and I can't just hold on to one side anymore in order to just perpetually climb the same wall. In order to wall jump back and forth and go up, we need to have an opposite wall now. So that is now working. We got the dust particles going over here. Our movement is looking fluid. It's looking fun. Now let's add enemies and hazards. So all platform games have hazards of some kind. That's what makes it a platform game. Like, don't fall off the platform and fall into the hazard and die. Others have enemies. Like, if you touch an enemy, your character dies and it's game over. So we're going to add a function here to handle death. But before we do any of that, you need to understand what parent and children objects are first. If a parent object has some attribute, then all the children objects share that same attribute. So we're going to create a parent object called O_bad. This is all the bad things that will kill our character. And now we're going to create another object and call it O_hazard. And we're going to set its parent right here to be O_bad. We're going to create one more object, call it O_enemy. Do the same thing, set its parent object to be O_bad. We're going to create a sprite for our hazard. Sprite, where are you at? There you are. S_hazard. Set its size to be 32 pixels by 32 pixels. Give it a color. Set its origin to be top left. Create a new sprite. Call it S_enemy. Set its size to be 20 pixels by 20 pixels. Apply. Set its origin to be middle center. And choose a color for it. Now set the sprites to their respective objects. O_enemy, it's that, and O_hazard, it's that. Now let's make it when the player touches either of these objects, the game restarts. We do this by targeting the code to our O_bad parent object, and since the hazard object and the enemy object both are children of O_bad, they are both considered part of the O_bad family. So the code will apply to them too. Create a new region at the bottom of the O_player step event and call it O_enemies. Oh, there we go. Region enemies and region, and write comment game over if place meeting x, y, o, bad. Oh, double close parentheses, open curly bracket, close curly bracket, game restart. Now open the room and create a new instances layer right here and name it bad. And put it under the instances layer. And click the layer to make sure that it's highlighted. Make sure it's selected so that when you're adding objects, it gets added to this layer. And drag some hazards and enemies into it. So let's add some hazards there. As a hazard there. Let me add, under instances, let me add a block here. To add an enemy. Change the grid a little bit. 16 by 16 for, oh, that's for the block instances. It's fine. Under bad, let's change it to 16 by 16. That way, when I add an enemy, add it close to the ground. And Let's add under instances one more block here. Add another enemy under bad right there. Let's run the game and test it. Our game should restart if we touch the hazards, which it does. We have to be careful. Touch an enemy. Game restarts. Game restarts. Good. So that's working. To make it seem more natural, we're going to set the collision mask for the enemy sprite to be 3 pixels left on the top, left, and right, but not the bottom because we're going to have it touch the ground and move back and forth. So let's go to the collision mask, set it to manual. 1, 2, 3, 1, 2, 3, and over here, 1, 2, 3. So it's a little bit of an overlap. So you actually see that the character overlaps with it and touches it before the character dies. Just makes it seem more natural. Again, perfection is the opposite of fun. And for the hazard sprite, collision mask, manual. Let's do it 10 pixels from the top. 1, 2, 3, 4. Oh, we just set it from here. 10 pixels from the top. The hazards can just stay still for now, but let's make the enemies move back and forth. And we can add some more complicated behavior in the future if we want. Like, we can make it so an enemy doesn't move until you're like a certain amount of pixels away from it, and it can chase you, etc. But for now, for this basic platformer tutorial, we're just going to make the enemy move back and forth. So we have added some enemies to our room, and we've added some walls so they can bounce back and forth on them. But we need to add some attributes that the OPlayer object currently has, like gravity and collision checks, and we're going to do some copying and pasting here. So let's close this room and create a step event for the OEnemy object. Step. And write the following code. Calculate horizontal movement. HSP equals current dir multiplied by HSP max. Calculate vertical movement. VSP plus equals grav. VSP equals clamp. VSP comma negative VSP max comma VSP max. Now copy the entire collisions region from the player object. Copy. And paste it in the step event of the enemy object. We might need to do some slight adjustments, but it looks pretty good. There we go. And we're going to add a create event and declare all the variables that we've just used. So HSP equals 0, VSP equals 0, HSP max equals 1, VSP max equals 10. So its max falling speed will be 10. Its max left and right movement speed will be 1. Pixel per frame. Current dir equals 1, but it'll be switched to -1, meaning going left, and then it'll be switched to +1, meaning going right. Grav is this, we'll make it the same as the player, 0.4. And now if we run the game, we should see our enemies touch the ground and move a little bit. But they only moved to the right. We want to make it so they touch a wall and then change directions. So to make the enemy change directions every time it hits a wall, like they're patrolling, we can just simply add this line of code. In the horizontal collision check, right after HSP equals 0, write current dir times equals or multiply equals -1, which will change directions. If the current dir is 1, it'll change it to -1, and if the current direction is -1, it'll change it back to 1. Check to see if it works. There we go. Now they're going left and right. Lastly, for the enemy's behavior, we can make it so the direction changes if they touch another enemy or a hazard. And this is going to be really lazy and really sloppy coding. It's not going to be elegant at all, but that's sometimes when you're just prototyping a game, that's fine. We're going to just copy the horizontal collision code and paste it right after itself, but before it commits to its horizontal movement. And we're going to just copy this, paste this, and change from O block to O bad. O bad. Let me change my notes a little bit really quick. So now, if it touches another enemy, say if I go here and I add under the bad layer, move this over, add another enemy, they will bounce off each other. And if I added an enemy over here, it would bounce off this hazard. Hits the wall, hits the hazard, and goes back and forth. All right, just to make things look more polished, let's update these sprites to be the graphics that I made for this prototype game. Go close this, go to s_hazard, import the appropriate sprites. So let's start with hazard 0 and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there should be 16 images total. It starts from 0 and goes to 15. Open that and set the animation speed to 15. If you hit play, you'll see that there's spikes that sort of come in waves. Make sure the collision mask is the same. It is, so it's a little bit below the spikes. That's good. So the player doesn't just touch this top corner of one spike and you're like, oh, I barely even touched it. You actually have to touch the spikes. And for the enemy, let's add enemy sprite, which should be S enemy. There's only one image. There we go. And the collision mask should be the same. So when we run the game, it should fit the game's look. Beautiful. All right, let's add some checkpoints. Before we make the game over or death more dynamic and interesting, instead of simply restarting the game, we need to add checkpoints so that when the player touches a hazard or an enemy, they will return to a checkpoint. Let's first create a checkpoint sprite. S_checkpoint. And let's change the canvas size to be 20 by 20 pixels. Apply. Edit the image. We need 2 images here, one for when the checkpoint is active and when it's inactive. The first one will be the inactive one, so let's make it like gray. And the second one will be active, so let's make it sort of this bright cyan. Change the origin to be middle center. And close that. Let's create a new object. Call it O_checkpoint. Assign the appropriate sprite. And before we add any code here, let's add a splash room where we can declare global variables. Global variables are going to be very important into this game overall, so we need a place to declare global variables before anything else happens in the game. It's important to do that before any code runs in your game. And one way to do that is through a splash room, especially if you plan on making this an HTML5 web browser game, which I do. So we're going to create a new room. I'm going to call it r_splash. Make sure that it's the same size as our first level because we haven't created a camera object yet to handle this. So 640 by 512. It's fine if it's all black. But we can go to the creation code and add some global variables, declare some. So global.checkpoint_room. So global variables, any object or instance or other place in the game can access and manipulate global variables. They're very useful. We'll set it to no one. Global.checkpoint x equals 0, global dot checkpoint y equals 0, global dot checkpoint underscore ID equals no one, room go to r level 1. Close that. Close this room editor. Now let's go back to our O checkpoint object. And in a step event, write if global.checkpoint underscore ID equals ID, so this is a built-in value that checks the ID of this one particular instance, open curly brackets, close curly brackets, image index equals 1. So that second frame, that sort of cyan frame. What? Unexpected error. Global.checkpoint equals ID. What's my syntax error? Oh, it's the parentheses here. Remove the parentheses. There we go. There we go. Else, open curly bracket, close curly bracket, image index equals 0, or that first frame, which is kind of gray. Let's go to our game level and rename the instances layer to player layer. It's more descriptive. And then we're going to add a few checkpoint objects to this layer, to a new layer, sorry. We're going to add a new layer, also call it checkpoints, on top of the player layer. And we're going to add some checkpoints here. Add a checkpoint like, let's change this grid so it's not snapping and so wide, 16 by 16. Add a checkpoint here. Add a checkpoint here. Add a checkpoint here. Why not? Beautiful. Close that. So now we want the game to record some checkpoint variables if we touch a checkpoint. So in that checkpoint object, in the step event, in the else statement here of when the global checkpoint ID is inactive, so this means checkpoint is inactive. We're going to add some code. If place meeting x, y, o player, double close parentheses, open curly bracket, close curly bracket, global dot checkpoint underscore room equals this room, whatever room we're in, global dot checkpoint underscore x equals the x location of this checkpoint, global dot checkpoint underscore y, same thing, the y position of this checkpoint instance, global dot checkpoint underscore ID equals ID. And then after that happens, it'll be the active checkpoint. So when it's not the active checkpoint, we can touch it and make it the active checkpoint, and it will whatever other checkpoint is currently active will check to will realize that it's not the currently active checkpoint, and it'll become inactive again. So let's check to see if it works. Now this doesn't save our game, but we should be able to see the sprites change. Oh, there's an issue. Global variable name checkpoint underscore ID index not set before reading it. I must have misspelled something. Splash room, creation code, global dot checkpoint underscore ID. It's no one. Global dot checkpoint underscore ID. Global dot checkpoint underscore ID. Should work. Oh, it's in the step event of O checkpoint. Global variable name. See, troubleshooting is an important part of this process, so I'm glad that y'all get to see even when I make mistakes. So this is on line 1. Right here. Let's just see if I'm spelling it correctly here. Yes, I am. Oh, do I need to do a double equal sign there? Man, I hope I don't have to edit this out. Let me just rewrite this really quick. If global dot checkpoint ID, see, I even just selected it from the variables that are already declared, equals ID, open curly brackets, image index equals 1, close curly brackets. It's not set before reading it. What is going on? You will see this issue yourself when you run tutorials. You might need to fast forward this section. This is O checkpoint. Oh my gosh. I know the issue. I know the issue. Okay, so the issue is very obvious once you think about it. This home symbol right here tells Gamemaker which level to, or which room to open up first. And because we declare our variables in the creation code of our splash room, and we didn't set the splash room to run first, these global variables aren't being declared. So we need to just go click right next to splash, click the home reorder or room reorder button, and just drag splash above our level 1, close that. Now you'll see a little home symbol next to our splash. So when I run the game, it should work now. There we go. Whew, that was difficult. So now it's working. I'm glad that y'all got to see it because that is the system of troubleshooting. It's just slowly but surely working through different possibilities and figuring it out. So now we have active checkpoints. If you touch one, the other one turns off and it becomes the active checkpoint. Boom, it's all working. Oh, all right, all right. Oh, that was hard. So now we're going to make it so the player goes to the most recent checkpoint that they touched if they end up colliding with an enemy or a hazard. So open our level 1 creation code and add if the instance does not exist, exists, O player. Notice that I added this bang or exclamation point before it, so it's checking to see if the player object does not exist in the room. Open and close curly brackets, instance create layer global dot checkpoint x global dot checkpoint y. The player layer O underscore player. We're going to create the player object with code in the room so that when the room loads, it'll move the player to the appropriate spot. So this also means we need to remove the player from the room. So just select the player object, delete it, make sure you have the player layer selected so you can actually control it, because if you don't have the right layer selected, it doesn't let you interact with these instances to delete them. And now we need to go to our splash room and set the global checkpoint variable so that it creates our player in the right spot in the room. So I want to create the player like right here, except a little lower, maybe. So where is that? That's like 305, 400. Let's try that. Delete it. Make sure you delete it. 305, 400. Oop. 305, 400. Let's run the game and see if, yep, our player gets positioned the right spot. Last step before we polish some things, we need to make it so the player touches, if the player touches an enemy or hazard, the player starts at the most recent checkpoint. And to do this, all we have to do is change the game over code in the player's step event. Close this. Enemies. Since we're going to be doing a lot of changes here, let's just change this from game restart to death, open, close parentheses, semicolon. And this is going to be a script that we're going to create. So go to scripts, create a new script, and call it what we wrote there, death. You don't have to add the parentheses, just write death. And in the script, we can write some stuff. If global.checkpoint ID equals no one, room restart. So if we haven't touched a checkpoint, room's going to restart. Else, open and close curly brackets, room, go to global.checkpoint underscore room. This is for when we have multiple rooms. So when we touch an enemy or a hazard, the room just restarts, but if we have an active checkpoint, we appear at that checkpoint. So let's make the active checkpoint this right over here, die over here. Yep. If I make the active checkpoint over here and I touch an enemy, the room restarts and I'm over there. Lovely. And since we just did a script to universalize something, let's do that to the room creation code. So every time we make a new room, this game is going to have several rooms. We can just write the script room code and then everything will be there. So let's close that, close this, and go to the level 1 creation code and write room code. Then copy what's here, and then create a new script, call it room code, and paste that there. And now you have a central space to alter all new rooms creation code. It's important when you're messing with scripts, if you ever rename a script here, you got to make sure you open the script and rename it here or it won't work. I could explain why, but it's not very important right now. You can read the documentation if you want to understand why. The reason why, in short, is that you can have several functions in one script, and if you're calling a script and you really mean you want this function, you just need to make sure this function and the script name is the same thing. Let's add some visual polish to the checkpoints before we move on to another section. In the S checkpoint sprite, you can import an image, import two images actually. They're like a little 1 and 0. So checkpoint 0, 0, checkpoint 1. There we go. Should be the same size. So the 0 should be the inactive one, so it should be the first frame, and the second frame should be the 1. And in the create event of the checkpoint object, we're going to make these checkpoints sort of grow and shrink a little bit. Grow equals 1. Scale max equals 1.1. Scale equals 1. Pop equals false. Grow speed equals 0.003. And in the step event, under the global checkpoint variables, add pop equals true. We'll make it gradually go back to normal. Scale equals 2. makes it pop big 2 times the normal size. Add a new section called animate and write some code. We're going to animate this checkpoint so it sort of throbs a little bit, and when you touch it, it pops. If pop is false, open curly bracket, close curly bracket. Let's close this room editor so we get some more room here. There we go. If, let's indent in. If scale is greater than scale max, or scale is less than 1, open curly bracket, close curly bracket, and leave a comment here. Go back and forth in size change. Grow, multiply equals -1. After that, scale plus equals grow multiplied by grow speed. Let's add an else statement. Else, open curly bracket, close curly bracket. Checkpoint just set. Make it big and then small again. If scale is greater than 1, open curly bracket, close curly bracket. Scale minus equals 0.03 semicolon. Else, open curly bracket, close curly bracket. Scale equals 1. Pop equals false. And then at the very end, outside of all of this, write image x scale equals scale, image y scale equals scale. So this will make the checkpoint grow and shrink slightly in intervals, and it'll feel more vibrant. And let's check to see if it works. Yep, so they're growing and shrinking a little bit, and when I touch it, touch the active one, it pops, so you can really see it. And we're going to add a sound effect later to emphasize it. Let's give some text so the player knows that this is actually a checkpoint. First, we need to create a new font. Create font. I'm going to call it f_default, our default font. And choose a good font. On Windows, I'm going to use Consolas, which is a console font. There we go. Consolas. On Macs, you can choose Menlo, which is a great font. Set the size to be 14. Set the style to be bold. You can come back and change this later if you like it or don't like it. And in the O checkpoint object, in its create event, add some variables. Text fade equals 0. Text fade max equals 90. Buff equals 5, which is going to be buffer in pixels on left and right of text for background rectangle. Text underscore y equals 30, meaning 30 pixels above the checkpoint, and text equals progress.save. The vibe of this game is like cyberpunk code programming, so I'm making all the text look like functions in programming, but you can also just write like checkpoint reached, or you can write just simply progress saved, but I'm going to make it look more codey, if that's a word. Progress.save. Now in the step event, let me make sure all the okay, these cautions are only up because we've only used these variables once, but that's not going to be the case in a bit. In the step event, add a new section, comment section, that will check if the player is touching the checkpoint, and if so, it alters some variables. I'm going to call it just text. If place meeting x, y, o player, close parentheses, open curly brackets, close curly brackets, text fade equals text fade max, no fading, text fade stays high. Else, open curly brackets, close curly brackets, text fade equals max between 0 and text fade minus 1, which reduces by 1 each frame until 0. So if the player is touching the object, the text fade variable will continually set itself to be the text fade max value. And if the player is not touching it, it will reduce by 1 until it reaches 0, which is important because we want the text to fade away a few moments after the player stops touching it. Now we're going to create a draw event. And in it, we're going to first write draw self, which means we're telling it to draw its sprite, because if you add any code in a draw event, it will override the sprite you assign and make the sprite invisible. But if you want to see the sprite, add draw self there. Draw the sprite. Now write draw set font f default, that font we created. Draw set h align, which is the horizontal alignment, to be center, fa underscore center. Draw set vertical alignment, or v align, vfa underscore middle. Local variable text w half, or text width, equals string width, so we check the string width of text, divided by 2 plus buff. And if you want, you can add some parentheses here to like make sure the order of operations is nice and clean. Var text h half equals string height of text divided by 2. We don't need a buffer for that. Make sure that gets declared. Yep. If text fade is greater than 0, open curly brackets, close curly brackets, draw set alpha, or how visible or transparent it all is, to be, and it's between 1 or 0, and it's like 0 to 100%. So 0.5 would be 50% or halfway transparent. 1 means fully visible, 0 means completely invisible. Text fade divided by text fade max. So that's going to give us a percentage that's going to make it how visible it is or not. Draw set color to be color that's appropriate for this game, which is going to be like aqua or cyan. Draw rectangle x minus text w half, comma, y minus text h half, comma, x plus text w half, comma, y plus text h half. Minus text y. Do I have plus text y? Minus text. There we go. I'm missing something. Missing something right. Plus text. Let's see. Well, I'm just checking my notes to make sure I wrote this right. Y minus, y plus, text h half, minus text y. Our text y is going to be how tall it is, so we need to make sure we add text y at the very end. So I was just checking to make sure I had that. Comma 0, meaning we want this filled in. Or you can write false, meaning the rectangle is filled in. Whew. Then draw set color be black. Draw text x y minus text y, comma text. Whew. And lastly, draw set alpha to be 1, because anytime you're messing with alpha values at the end of a draw event, you want to set draw set alpha to 1, or everything in your game is going to become invisible. Make everything else not fade. Okay, so this code will check to see if text fade is greater than 0, and if it is greater than 0, it will show the text. It will also set the alpha depending on how much of text fade is left. When it's the same as text fade max, the alpha will be 100%, and when the player steps away, that percent will gradually reduce every frame until it hits 0 and disappears. And be sure to draw this draw set alpha 1 at the end of the draw event. So let's see if this works. All right. Oh, see, there is an issue. Bug. It's not working. And I'm pretty sure I know the issue. The issue is with this background rectangle. So let's rewrite this and make sure I'm doing it right. Draw rectangle x minus text w half, comma, y minus text h half, minus text y, comma, x plus text w half, comma, y plus text h half, minus text y, comma, 0. I think that's our issue. We just needed to make sure to add minus text y after here and after here. Just make sure that it is 30 pixels above the checkpoint. Yep. It is now working. So when I'm touching a checkpoint, it just stays there, progress save. When I move away, it gradually fades away. Beautiful. Got a little semicolon here, I think. It's part of the string, make it look a little better. All right, we have a checkpoint system. And now let's add a combat system, a very simple combat system. Now you can adapt this combat system to be more complex. You can just change the code around, but I went for the most simple version of combat that I could think of. In level 1, this room, let's add a new instance layer right above the player layer and call it weapon. Close that, create a new sprite called s_weapon. Set it to the appropriate images, which is 4 images: attack 0, attack 1, attack 2, attack 3. Set the animation speed to be 20 frames per second, and its origin should be middle center. Close that. Create a new object. Call it O_weapon. Set the sprite. Now let's add an attack key to use our weapon. So in the OPlayer object, go to the create event, and under player inputs, add key_attack equals 0. And then also add an attack section. Attack_cooldown equals 0. Attack_max equals 20. Number of frames before we can attack again. Now in the step event, under player inputs, add key attack equals keyboard check pressed VK space. Our space bar is going to be our attack. And we're going to add a new region underneath our current status and animations. And we're going to call it region attack and region. If attack cooldown is greater than 0, open curly bracket, close curly bracket. Let's add a comment. If attack cooldown isn't 0, reduce it to 0. I bet you can guess what I'm going to write here. Same reduction code that I've been using other places. Attack underscore cooldown equals max 0. Attack cooldown -1. Else, open curly bracket, close curly bracket, and let's add a comment. If it is 0, then player can attack. If key attack, which is saying, hey, if key attack is active, or if key attack is 1, or if key attack is true, open curly bracket, close curly bracket, attack underscore cooldown equals attack underscore max, semicolon, comment, set the cooldown timer, and instance create layer X, Y, weapon layer, O, weapon. So if our cooldown timer has reached 0 and we can attack, it creates our weapon object. So let's see if it works. Yep. So wherever I go, if I hit the space bar, it's creating our weapon object. But we're going to make it so the weapon object, also we can't spam it. It's 20 frames before I can create a new one. And now, in the O weapon object, we're going to add an end step event. So go to step and then go to end step. We're going to write code to make the weapon follow the player. If instance exists, O player, if the player object is alive, open curly brackets, close curly brackets, x equals 0, no, x equals O player dot x, y equals O player dot y. Else, open curly bracket, close curly bracket, instance destroy. So this end step event is very useful because it runs after every other step event has completed. This means that the O player X and Y locations are already set, so the weapon can stick to the player perfectly. So we can check to see if it works. Yep, it's following the player now. It's following the player perfectly. Good, 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 good. And in the O weapon create event, we're going to declare some variables to animate it slightly and to make it disappear after an amount of time. So write timer equals 0. Image index equals I random range 0 to 3. Flipped equals I random range 1 or 2. If flipped double equal sign 2, image x scale equals -1. So every time the weapon is created, it'll just like flip its orientation a little bit, just randomize it. And in the step event, regular step event this time, right? If timer is greater than 0, open curly bracket, close curly bracket. Timer, double minus equal sign, so reduce it by 1 every frame. Else, open curly bracket, close curly bracket. Instance destroy. And we shall see if it works. Now it should destroy our weapon. Oh, destroys it immediately. Did I accidentally set the timer to be... Oh, timer shouldn't be 0. Timer should be like 8 frames. There we go. I just misread my notes. Yep, so this way there is a cooldown for the attack. The attack turns on for 8 frames, which is good. And finally, in the O enemy, step event, specifically O enemy, not O bad, because we only want to be able to fight enemies. Make it so if it touches the weapon, it gets destroyed. So in the step event, at the very bottom of everything, I'm going to write defeat if place meeting X, Y, O weapon, double parentheses, open curly bracket, close curly bracket, instance destroy. And now, if our weapon touches the enemy, it should kill the enemy. So let's get to this enemy over here. Just have to time it so it doesn't touch me. Yep. Oh. Hey, I thought I want to be able to... There we go. Got both of them. Kill this guy. There you go. Let's give the enemies a little explosion animation in order to accompany their deaths. Let's create a new sprite. Call it s_explode. And import the explosion images. S_explode 0, 1, 2, 3, 4, 5, 6, 7, 8. So there's 9 images total, starting with 0. And the frames per second should be 30, and if you hit play, you see the explosion. Set the origin to be middle center, that's very important. Create a new object, call it O explode. Set its sprite to be the appropriate image. And add under other the end animation end event, right, instance destroy. Now in the O enemy defeat section, add this above where it destroys itself, right, instance create layer X, Y, the bad layer, O explode. So now when we defeat enemies with our weapon, they should give a little explosion animation. Yep. And after the animation ends, it destroys itself too. So it only animates once. And yeah, so I have that all. Yep. Everything's working. So ways to play around with this system to make it more versatile, you can add like a stamina system so that the player can attack repeatedly until they run out of stamina, and then their stamina bar needs to recharge. You can see this in my game Fetch Quest, the Tiniest RPG, which is on my website. I have a stamina system like that. You can also change the weapon to be like a sword or something and make it so it only attacks on one side of the player, whichever direction the player is facing or the player object is facing. You could make the weapons projectiles that shoot out from the player. There's a lot of flexibility here, but this gives you a basic system to work with. And that's it for the weapon system and the enemies and the checkpoints. And our next video, we're going to look at creating a game camera system, camera shake, and adding some room transitions. So yeah, good luck. See you in the next video.